All right, today we're going to talk a little bit more specifically involving the law of reflection, and we're going to do convex and concave mirrors and how to draw array diagrams for them. So the first one we'll talk about is concave mirror. Concave mirror is also called a converging mirror because the light rays come into the mirror and they converge at a single point. All of these rays will come into this mirror, and because of the shape of it, they're going to converge at a single point. That point is the focus if all the light rays come in parallel to each other. Converging mirrors have a positive focus. Important thing to know, I would circle that if I were you and write in your notes that a positive focus means that the focus is on the front side of the mirror. So this is the reflective surface here. All the light is on this side and the focus is on the front side of the mirror. And remember that concave mirrors means the reflective surface is quote unquote caved in. Let's look at some concave mirrors. I've actually got three types of mirrors here. One is a flat mirror. You can see my face in it, and it's pretty scratched up, but that's a flat mirror. I'm going to put a curved mirror in the same place and look at the difference. So there's one that's curved in the same place. Notice that we have a quite large image. And then on the other side, so this is concave on this side. On the other side is a convex mirror. Notice the difference there. So this is convex. This one's concave. And that's a flat mirror. Right, differences in these three. I want to focus on the concave for right now. You'll notice that the mirror is pretty big here. And let's see if we can get this to work. If I put the mirror pretty far out, I don't know if we'll be able to see this or not. Yeah. So do you see that word back there? Look in the mirror. You'll see a word, and hopefully you can figure out that the word is acids, but it's upside down. And let me show you where the word is right now from where I'm sitting. There's the word. There's the acids cabinet that's right behind me. And so you'll notice that that in this concave mirror, there's some different images. So if we look at the image of, let's see if I can find that thing again. There it is. So there's the acids cabinet. If we look at an image of something that's far away, the image is inverted. But if we look at the image of something that's close up, it's actually upright. My face is upright, and it's really big. All right. This is your makeup mirror. Your makeup mirror looks like this. Your makeup mirror is a convex mirror. And let's also talk about some other examples. So makeup mirrors are convex. Telescopes, if you have a telescope at home, one of the big ones, the large ones, there's actually a concave mirror at the bottom. Light rays from the stars come into this concave mirror. Once again, it's called a converging mirror because all these rays will converge on each other at a single point. Usually there's another mirror, small mirror here at this point. That light gets reflected out into the eyepiece, and here's your eye, and that's what you see, images of the stars. That's how a telescope works. So we got makeup mirrors, we got telescopes, headlights. Your headlight is actually a parabolic concave mirror, and the light bulb is directed inward toward your car instead of outward. And the reason is because the light rays go out in all directions. That wouldn't work very well if it was directed toward the outside of your car because the light rays would go out in all directions and the light would be too diffuse. You wouldn't be able to see anything. But because it shines on this mirror, because of the shape of the mirror, everything reflects off of the mirror parallel to itself, and so the light actually comes out like this, very directed headlight beam. Okay, so telescopes are examples of concave mirrors. Headlights are examples of concave mirrors. And by the way, back to the telescopes, we're talking about visible light here, but remember that visible light is no different than any other kind of light. There are also telescopes that are made for radio reception. Not radios that we listen to, but the stars actually produce radio waves. There are huge 300-meter radio telescopes that literally receive radio waves from outer space and direct them back up to a certain place, and computers process those radio waves and make a radio image of outer space. You can look these up. There's one in Arecibo, Puerto Rico. It's a radio telescope. This same thing, you might notice, it kind of looks like a dish satellite. right? And dish satellite is the same thing. What happens with satellites is here's you in your house, and here's the cable company, and they don't want to run wires directly to your house. What they do is they take advantage of many satellites that are actually orbiting the Earth. And so what they will do is they will send a radio or a microwave signal up to that satellite. The satellite then sends the signal to your house, to the dish in your house. So the signal comes down and you're able to get your satellite TV, whatever. But the point is, what happens with the dish is all of those radio waves, microwaves, whatever they are, come into the dish, which is really just a concave mirror that's designed to reflect radio waves and microwaves instead of visible light. And all of those rays will be reflected to the center, to this focal point. By the way, you can actually use a concave mirror. The physics teachers did this the other day to burn stuff, because light rays come in and all the light that falls on this surface is reflected and focused at a single point. So we have all this energy here that gets focused at a single point, and it gets really hot right there. The physics teachers took one of these out the other day and burned some paper, and actually possibly could have burned the face of a Barbie. But anyway, those are concave mirrors. Concave mirrors, here's the picture of ray diagrams coming in. The rays come in parallel, they reflect, and they converge at a single point. And actually do keep going past each other, but that's more than what we need to talk about now. Convex mirrors. Convex mirror is called a diverging mirror, not a converging mirror, because the light comes in and it diverges, it goes away from itself. They never come back to a single point. Diverging mirrors have a negative focus. Remember that a converging mirror had a positive focus, which meant the focus was in front of the mirror. Negative focus means that it's now behind the mirror, and we'll talk about exactly what that means. Convex mirrors, again, let's look at one of those. This was your convex mirror. There's my face. Everything is smaller in a convex mirror, and notice that, let me do this. Notice that no matter how far away I get, the image is still small and it's still upright. It doesn't matter where I am. This image is still very small and it's still kind of distorted looking. So convex mirrors, examples of convex mirrors are bus mirrors, side view mirrors. The mirror on the passenger side of your car says objects in mirror are closer than they appear, because your passenger side view mirror is actually slightly convex, which means the object seems smaller and your brain says smaller is farther away. I mentioned buses. Buses are required to have convex mirrors on the front corners of the bus so that they can see actually in the front of the bus, to make sure that there are no children walking in front of the bus before they drive away. So these are convex mirrors and concave mirrors. Here's the ray diagram of rays coming in, and they diverge away from each other. Now notice, we'll talk about these in a minute, but we have these dotted lines behind the mirror where there actually is no light, but they're called virtual rays. Real rays and virtual rays. We'll get to those in a minute. Two types of images that are formed. There are real images and there are virtual images. This is where things gets really interesting. Real images are formed by converging rays, and these rays are real rays. That's why they're called real images. You might want to write that down. Since they're real rays, they can be projected on a screen. Therefore, at least in class, the image that we see on the screen from the projector is a real image. It's formed by real light rays. And real images are always inverted. As opposed to virtual images, which are really cool, real images are formed by diverging light rays, which never do actually come together. In other words, real images, or virtual images rather, are formed by virtual rays. And the word virtual means, as I think you know, not real, not actually there. These images are actually made up in your mind. Not made up, but your mind is smart enough to put them together. They aren't actually there. They cannot be projected onto a screen because they aren't formed by real rays, and virtual images are always upright. So these things you got to know. Real images are always inverted, virtual images are always upright. If you're wondering what I mean by this virtual image thing, let's go back to this picture. Convex mirrors, which is what this is, always form virtual images. Because what happens is the light rays come in and they diverge away from each other. These are real rays. We use solid lines to represent real rays. We use dotted lines to represent virtual rays. Since the real rays never come together, they never converge, you cannot form a real image with this. Therefore, you cannot project the image onto a screen. This is the concave mirror, and you might notice, if you look closely, look at my hand, and you might actually be able to see an image of what is right now the lights on the ceiling, because I'm projecting that image onto my hand using real light rays. Those are real light rays falling on my hand, because that image can be projected onto a screen, which is my hand at this point, and I can form a real image. However, if I use the convex side, so this was concave, it's big image, convex, small image. If I use the convex side, if you look at my hand, you'll notice I cannot form an image of those lights. I can't do it. Convex sides of mirrors do not form real images. The reason that happens is because here's your eye down here looking at this light. The light falls on your eyes, but your eyes don't know about reflection or refraction. Your brain, rather, doesn't know about it. It doesn't know the light came from back here. Your brain automatically traces light rays in straight lines. It thinks, quote unquote, thinks the light ray came from back this way. It traces a virtual ray back here. And realize it's called a virtual ray because it's not actually there. All the light is on this side of the mirror. No light gets through. But your mind can trace that ray back. And it's actually a pretty powerful tool. And what's interesting is that if these virtual rays, if they were actually there, if they can cross at a single point, your mind will form an image of all the rays that it's receiving, can form an image at that point. In other words, when you look into a convex mirror, it looks as if the image of your face or whatever it is actually behind the mirror, when we know it's not. We know there are no light rays back there. So that's a virtual image that your mind forms because it's able to trace these rays back to where they came from. Somebody texted me. And it forms an image at the point where they would have intersected. So real images and virtual images.